Understanding the basics of CAN protocol. Welcome to this video on the Controller Area Network, or CAN protocol. CAN, short for Controller Area Network, is a robust communication protocol primarily used in automotive systems. It enables various electronic control units, or ECUs, to communicate with each other without a central host computer. Think of it as a universal language for your car's brain. What makes CAN so effective? Here are its key features. Multi-master architecture. Any ECU can start communication. Robust error handling, fault detection and correction ensure reliability. Efficient message prioritization. Critical data gets priority. High-speed communication. Support speeds up to 1 megabit per second. These features make CAN ideal for coordinating components like anti-lock braking systems, airbags, and even advanced driver assistance systems. Now, let's break down how messages are sent in CAN. The CAN frame consists of several fields: the start of frame, arbitration field, control field, data field, CRC field, acknowledgement field, and end of frame. Each of these fields has a specific purpose in ensuring smooth and reliable communication within the CAN network. Now, let's take a closer look at each of these fields. First, we have the start of frame. This is a single bit that marks the beginning of the CAN frame. Next is the identifier. This field specifies the priority of the message during arbitration. The identifier comes in two types: the standard identifier, which is 11 bits long, and the extended identifier, which is 29 bits long, offering more flexibility for unique message IDs. And the RTR bit, or remote transmission request. This bit indicates the type of frame being sent. If the frame is carrying data, the RTR bit is set to 0, which is the dominant bit. For a remote request, the RTR bit is set to 1, which is the recessive bit. Following the arbitration field is the control field, which is 6 bits long. This field contains the IDE bit, which indicates whether the frame uses a standard identifier, set to 0, the dominant bit, or an extended identifier, set to 1, the recessive bit. A reserved bit, typically set to dominant 0 for future use, and the DLC, or data length code. This 4-bit field specifies the length of the data field, ranging from 0 to 8 bytes. The data field follows next. This field holds the payload, with a maximum size of 64 bits, or 8 bytes. After the data field comes the CRC field, which ensures the integrity of the data. This field is 16 bits long and includes a CRC of 15 bits, representing the checksum used to detect errors in the frame, and a CRC delimiter, a single recessive bit that separates the CRC from the next field. Next is the acknowledgement field. This 2-bit field includes an acknowledgement slot, where receivers acknowledge a correctly received frame by sending a dominant bit, and an acknowledgement delimiter, a recessive bit separating the acknowledgement slot from the next field. After that, we have the end of frame. This field is 7 bits long and consists entirely of recessive bits, indicating the conclusion of the frame. The CAN protocol works at the data link layer, where it handles message framing, error checking, and arbitration. It also relies on the physical layer for sending and receiving data. To summarize, the CAN frame format consists of several fields: the start of frame, arbitration field, control field, data field, CRC field, acknowledgement field, end of frame. Each field plays a vital role in ensuring reliable and efficient communication within the CAN network. That's a wrap on the CAN protocol basics. In upcoming videos, we'll dive into advanced topics like the arbitration process, collision avoidance, types of errors, and much more. Thank you for watching, and stay tuned for more insightful content.